8.3, number 34, we got an integral from 0 to 2 of this, so we could think of it as from 0 to 2 of the left minus integral of 1 over 2x minus 2 dx from 0 to 2. Alright, so we have two separate integrals, kind of. It's all within one integral, but if this diverges or this diverges, then the whole thing diverges. This much of it. So I'll show you a couple different ways of doing the problem. I'll find the antiderivative, and I'll actually, rather than using tests, use the antiderivative approach, and then I'll show you how limit comparison test would also come to the same conclusion. We're trying to figure out if this converges or diverges. So I'm going to take a 2 out of the bottom. And left with x minus 1. So we're going from 0 to 2. It's an improper integral because 1 is not in the domain. So we're going to have to call that our c value. I'm going to leave this negative 1/2 out right now. And we can multiply it by whatever we get on at the end. But for right now, I'm going to integrate from 0 to c as c approaches 1 from the left, plus limit, well, the integral of 1 over x minus 1 dx from c to 2 as c approaches 1 from the right. Alright, so we had to break it up into two integrals because of the vertical asymptote at x equals 1. Okay, so let's look at the left hand side. We can find the antiderivative of 1 over x minus 1. That's just the natural log of absolute value of x minus 1. So we're going from 0 to c as c goes to 1 from the left. If I plug in your 1, so you get natural log of 1 minus 1 minus natural log of 0 minus 1. Okay, so 1 minus 1 is 0. Natural log of 0 is not a real. You can't take the natural log of 0. So since we got that, this portion diverges, so the whole integral here diverges, so the number 34 diverges. So therefore diverges. Okay, if we wanted to, still focusing on this same integral right here, if we wanted to compare that to 1 over x, so I'm going to do that down here. I'm going to leave the negative 1/2 out because it really doesn't play a part. So integral of 0 to 2 of 1 over x minus 1 dx. We're going to show that that diverges using the limit comparison test. Alright, so it's 1 over x to the first, so p equals 1. Kind of, but we can only do the p test when we're going from like 1 to infinity or a small constant to infinity. So the p test does not work here, but if it does compare to 1 over x, it's basically the same thing. So we find the limit as x goes to infinity of that, multiply the top and bottom by x minus 1, so we get x minus 1 over x. You could do L'Hopital's or just compare the coefficients 1 over 1, so we end up getting 1. So they do behave the same. Alright, so now if we know if this integral from 0 to 2, if we know that converges or diverges, then we know that this integral converges or diverges. They behave the same. So in this one, we can find the antiderivative, natural log absolute value of x. We have the point of discontinuity is 0, so we do have to go from a to 2 as a approaches 0. And then we can drop, we already found the antiderivative, so we get the natural log of 2 minus natural log of 0, which we can't do. So this integral, therefore 1 over x from 0 to 2, that diverges. So if this one diverges, then this one would also diverge using the limit comparison test. Diverges limit comparison test. So two ways to show that this original integral diverges.